Welcome back, everyone. So now that you have watched a video lesson on some applications of sine and cosine and worked with graphing sine and cosine and writing equations and analyzing the equations in the graphs, we're going to do some more practice with applications. So as I shared in my last video, I would be going through the homework in this video. So I'm going to go through another example of trig modeling and application and how you interpret and make predictions and graph and write models or equations. I lost my train of thought there for a second. So I'm going to go through an example, and then I am going to be going over your homework worksheet, part 2 of it. So hopefully you have that with you, or if you don't, maybe pause the video, and if you have a printer, print it out or pull it up or have something that you can write on and reference. I would really encourage you to have read through these and tried them prior to going over it. It's almost like a video answer key, right? So that I can explain things and you can kind of check your work along with me. So let's get started. Let's start with this example, which if you notice, we're not using a calculator. So the tide, right? That was one of the examples or one of the situations that can be modeled sinusoidally, right? It follows that trend. So the depth of water at the end of a pier varies with the tide throughout the day. Today, high tide is at 4 a.m. with a depth of 5 meters, and low tide occurs at 10 a.m. at a depth of 1 meter. So here we're being asked to find the amplitude, the vertical shift, or the sinusoidal axis, right, that midline, as well as the period, right? So these are really the 3 things we were doing, regardless of being asked, in order to generate a model to make some predictions. So the amplitude, I want to know the range, right? So I'm going from the lowest is 1 meter, the highest is 5 meters. So the range of this is 4 meters, and the amplitude is going to be half of that. So the amplitude we're working with here is going to be 1 meter. The vertical shift is in the middle of high tide and low tide, right? It's that balancing point, or that balancing line in between. So halfway between 5 and 1 is going to be 3, right? I can add them together and average them. So the vertical shift is 3 meters up. The sinusoidal axis would be at y equals 3, which is important for us to remember. Finally, the period, which is explained here, it's how long does it take to go from high tide back to high tide, so that 1 rotation. So I know that high tide happens at 4 a.m., low tide at 10 a.m., so that's 6 hours. So plus another 6 hours to get back there. So the period would be 12 hours long. So if we use this, we're going to go ahead and actually sketch a graph of it. Right, so I'm dealing with, this is it hours after midnight? Let me come back for a second. This is going to be the depth of the water in meters. And I'm going from 1 to 5, so 1, 2, 3, 4, 5. And then 4 a.m., so it's the hours after midnight, so So I'm going to go to, it really doesn't say too much, but I'm going from 4 a.m., 1, 2, 3, 4, to 10 a.m., 5, 6, 7, 8, 9, 10. So that's 6, and then 1, 2, 3, 4, 5, 6. This would be 4 p.m., which is actually going to be 16, right? That would be 4 p.m. That would be one cycle of it, and so that's really what I'm going to focus in on graphing. So at 4 a.m., we were at high tide, which was 5 meters. Oh, my goodness. 4, 5. At 10 a.m., it was 1 meter. And then at 16, we're going to be back up here at 5. And that's 4 p.m. again. Right? And it keeps going. It goes back down. I'm going to go ahead and graph the sine soil axis, y equals 3 as well. And if you, I maybe should have started with this piece of it, but I could go ahead and graph like the road as well, so I know that I'm staying in between. Determine the equation that best models, or that models this situation, that models this depth. So I'm going to go ahead and I'm going to use cosine and focus in on this part that I've graphed. So I already know the amplitude. We talked about that. The amplitude was 2 cosine. The period was 12 hours. So it would be 2 pi over 12, which is pi over 6. X, it's starting at 4, so minus 4, plus the midline, which is 3. Find the depth of the water at 1 p.m. Well, I guess I can go ahead and do this in quarters, right? 1, 2, 3. That's 1 p.m. Isn't that 13, 3? This would have a depth of 3 meters. It's actually one of the quarters. If I wanted to just use my formula, my equation, my model that I wrote, I could go ahead and we can even check this and see what happens. Right? This is something we can do without a calculator. Y equals 2 cosine of pi over 6 times 13 minus 4 is 9. So this is 9 pi over 6, which is 3 pi over 2. So it's 2 cosine of 3 pi over 2 plus 3. Well, cosine of 3 pi over 2 is down here, right, on the circle. So that's going to be just 0. 2 times 0 is 0, so 0 plus 3. Oh, wow, I get 3. Cool. And finally, for this question, a large boat needs at least 3 meters of water to dock. When are the hours during this day that the boat can dock? Right, so here's the parts that I might care a little bit more about what's happening here. So if I went, each quarter is really happening like at 3 hour increments, right? Those are my quarters. 12 hours divided by 4 every 3 hours is where I'm getting to one of these critical points. So 4, 5, 6, 7. If I go back at 1, and then it's going to be below it, right? So at least 3. So it would have to be between 1 a.m. and 7 a.m. 1 to 7. And then this is 1 p.m. to, what happens here? 16, 17, 18, 19, which is what? 7 p.m. Right, and then it's going to be below. I don't know why I put a point there, sorry. It's going to be below, it's going to get to its lowest point 3 hours later, 19, 20, 21, 22, which is what? Not 10 p.m. is when it's going to get to its lowest. 10, 11, 12, 1 is when it's going to get, like, the next day, right? So those are really our increments there, right? Or I can even write it more as a 1 is less than or equal to x is less than or equal to 7. 1 p.m. is 13, so 13 is less than or equal to x is less than or equal to 19. If I wanted to go in that direction with this one. Awesome, right? So no calculator needed for this. It all kind of worked out with special angles over here, or just being able to read our graph. So let's go ahead and let's take a look at our homework assignment here. Sorry, I already wrote on it. That's not good. We're going to pretend we didn't see this. It's good enough erasing. I'm going to rewrite on it. Okay, so for this right here, this is what we know or what we're working with. So you just built a dock for your new boat over an inland waterway. The top of the dock is 13 feet from the bottom of the waterway. So here's my dock. Whoa. So here's my dock, let's say, and here's the bottom of the water, right? The bottom of the water is never changing. The distance between it, if this is my dock, is 13 feet regardless. This is the bottom of the water. The water can be a variety of different heights, obviously, right? So at low tide, the water is a depth of 5 feet. So like here's the water. So at low tide, it has a depth of 5 feet. At high tide, it has a depth of 2 feet. I'm sorry, 2 feet below the dock. I said it, and I was like, that doesn't make any sense. 2 feet below the dock, right? So at high tide, this right here is 2 feet. Well, this whole thing is 13. So this would be high tide is going to be 11 feet, right? So we've now identified what our high tide and what our low tide are. So when we're talking about a model, right, or a graph, right, an equation, you know what? I'm even going to go down here, I think, on my paper. What is that dot then? What is going on? And I'm going to say, I know what the amplitude is, don't I? I know the amplitude is going to be, well, that range right there is 8, so my amplitude is going to be 4. Even more, I know the midline or the sinusoidal axis is going to be at y equals 8. Right? I know these things before I even go ahead and write the equation or think about what this looks like. So you found a tide table, and you know that the next high tide of 11 feet is going to happen at 2:17 a.m. So we're just looking at Saturday here. And the next low tide happens at 8:31 a.m. If the tides ebb and flow over time in a periodic manner, use the cosine function and sketch a graph of the tides over the next 24 hours, as well as we're also going to be writing the model or the equation. So if I go ahead and I try to graph this, we can choose to either work in minutes or hours, but we should probably just make sure that we're writing it down and making it evident which one it is. I'm going to choose to work in hours. I'll do hours. I'll go ahead and do hours this time. So we can work in hours through this. So I know that high tide is going to be, so I'll go ahead and it's 11, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is the depth of water in feet. This is 1, this is 13, this is 5, this is 8. So I kind of just wrote down some key values. I know that 11 is the high tide and 5 is the low tide. 1, 2, 3, 4, 5. And 8 is the middle. I'm just going to go ahead and do that. So what the other things that I know are that high tide is going to happen at 2:17. And I'm looking at this whole day. So I'll make it go to 24 hours. All right, and I'll kind of just break this up. 12, 6, 3. So this is 1, 2, 3, 4, 5, 6, 9, 7, 8, 9, 10, 11, 12, 18, 15, 16, 17, no, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I tried to space it out. It didn't work out perfectly, but it's not bad. Okay, and so this is the hours after midnight on this particular Saturday. So at 2:17, it is high tide, which is 11. right? So let's go ahead and 217. So 17 is what fraction? 17 out of 60. It's like 2.28, right? So that's really what I'm using since I'm looking at hours after midnight. So at 2.28, it's at high tide, which apparently I can't plot a point there. 2.2811. At 8:31, 31 is what fraction of an hour? We know it's going to be a little bit more than 0.5. So like 0.52. I'll go 2 decimal places. So at 8.52, 6, 7, 8.52, we're at low tide. 8.52, we're at low tide, which is 5. Okay, so if I'm going from 2.28 to 8.52, 8.52 minus 2.28, I'm going to go ahead and I'm going to get 6.24. Right? That's like half the cycle, not like the half the cycle. If I double that, I get 12.48. So it's 12.48 hours. It's a little bit less than 12 and a half hours. Would actually be, I think it's actually 12.48 times 60. It's like 28 minutes, 29 minutes. Is actually, that's the period. Right, so if I go ahead and based off of this, I'm going to go ahead and add 6.24 to 8.52 to get that other point, 6.4, 14.76, like right around 14, right around here. I'm going to get back to high tide. Goodness. 14.76. That's 11. And then if I go ahead and I add half of the period again, I get 21. I would get back to low tide. So 21, and that's, what is that, 5? Right, so I'm going to be almost at like the middle here, right at the end. Right, so you can kind of see like, oh, that's not very good. What is kind of happening for those 24 hours? Probably going to be like right about there. Cool. For my equation, I have actually a lot of the information. I have y equals, we already talked about the amplitude, cosine. I'm going to focus in on that part of the graph I was given, right? So it's going to be between here and here, really, is what I'm looking at. So cosine, the period was 12.48. So I'm going to go ahead and do 2 over 12.48, 2 pi over 12.48, which would simplify. I mean, I could get a nice fraction if I wanted, or I could write it like that, I suppose. Pi over 6.24, I guess, is what I could also write. X minus 3. Right, because I'm starting at, no, not minus 3, minus 2.28. So sorry, I keep forgetting that I have the eraser. And then plus 8, right? So I already found some of that information. Right, so we can go ahead and we can kind of use this equation. We can figure out different things. We can look at the graph of it. We can check it, all of that fun stuff. And if you did it if you converted everything to minutes, that's fine as well, right? I could go ahead and instead of saying 2:17 a.m. is 2.28, I could go ahead and say that would be what, 137 minutes, right? And that would, you're going to get the same result. You just want to indicate that we're working with X in terms of the number of minutes after midnight instead of the number of hours after midnight. Okay. Great. So at what depth will you first need to use a ladder, right? So a ladder, for safety's sake, you must use a ladder if the upper edge of your motorboat falls more than 1 foot below the dock. Your boat has an exposed height of 3.5 feet. So let me draw this again. So here's my dock. Here's the dock. And this is, again, this distance is 13. If it's 1 foot below, that's when you need a ladder. So down here. Right, so this distance, that blue distance is 12. Right, this little thing in here, that's 1 foot. So if your boat is less than this, like it's got at the top of it's got to reach that. Right, the upper edge. And so I'm going to go ahead and I'm going to attempt to draw my boat. Ugh. Right, and my boat, the part that's exposed from the water, is 3.5 feet. So what's the height of the water down here? Right, and anything below that, I would need a ladder for. So this right here, like we know now it's 12, so I've got 12 minus 3.5. Or I could have done 13 minus 4.5. And that's going to give me 8.5. So anything below 8.5. You need a ladder for anything below 8.5 feet. Let's go back and let's mark that on our graph. 8.5. So a little bit above the midline, right? Eight and a half feet. What time intervals will you need to use the ladder over the next 24 hours? So which time intervals, right? So I'm really looking at, I highlight in different colors. Sweet. If it goes below this, right? So I'm looking at really like here to here, here to here. There might be a little bit over there as well. I'm not sure. We'll look at it. We'll get a little bit more information, right? So we need to figure out what those points are. So really what I'm trying to find is 8.5 equals, I don't know why I'm writing it like that. 8.5, now that I'm thinking about it, equals to, what was my equation? I already forgot it. It was 3 cosine of pi over 6.24 x minus 2.28 plus 8. So I'm trying to find this, right? And there's going to be, like, it repeats. Don't forget that it repeats. So let's go ahead. Let's actually go into our calculator. So I'm going to make this smaller and keep my annotations. Let's put this in here. So you've got 3 cosine of pi over 6.24 x minus 2.28 plus 8. Let's see, what's my window? Did I already do this? So I'm going to go from -1. What are some things I want? The x maximum, I'm going to go to like 25 so I can see this full day. And then I'll make it go from 0 to 13. Let's go ahead and graph it. Woo. Right, so I want to know, let's see, y equals 8.5. Right, so I want to figure out where does it go. Am I looking for below, I believe? Right? Yeah, below. So I'm looking for below. So I want to find these points in here. And I'm going to go back here, and this is where I'm going to actually record what these points are, I believe. So let's trace it. Second trace. Let's find the intersection. So this right here, oh no. That point right there is 5.06, 8.5. Then I want to know this point, so let's keep it going. Second trace intersect. No, I pushed a button. Second trace intersect. Enter, enter, enter. 11.97. And then I want to know this point. I've got two more, right? I think so. So second trace intersect. $17.55. And then let's see, is there one more? So you look at the hours. Is that before we get to 24? Well, not really, but it's okay. 24.45. So what are the hours? What are the time intervals that we'll need to use a ladder based off of all this information? Well, between the hours of it's 5.06 is less than or equal to, or I guess not equal to, right? Because you don't need it. 5.06 is less than. X is less than 11.97. And, wrong one. And what else? We'll also need it between 17.55 and 24.45. Right? And if we wanted to convert these to times to make it a little bit more sense, to make it be a little bit more sensible, I could go ahead and figure out like, well, 0.06 of an hour is going to be 3.6 minutes. So like this is going to be at like 5:04 to 9.97. Sorry, 0.97 times 60. 58, so to 1158. This is approximate. 55.55 times 60, 33. So the 17 is what? This is 5:33 p.m. So this is a.m. This is a.m. To 4.45, 3/4 of an hour is what? 3/4 of 60 is 40. Well, oh, I'm sorry, that's not 40. I'm all messed up. Sorry. This is after midnight the next day, but 0.45 times 60, 27 minutes. So like this would be at like 12:27 a.m. the next day. So this would be on Sunday. Okay. So some interesting ways to interpret and apply this and think through what each part of it means. Let's take a look at the second question about Ferris wheels. So at the local carnival, you decide to ride the Ferris wheel and determined it would make a great problem for math class, right? A lot of you guys talked about this. You said about the gazelle and the lion. I feel like this was the reason. I think we do these things just for math problems. Since you realize your distance from the ground is a function of your travel time, the Ferris wheel, as shown to the right, here's our Ferris wheel, has a diameter of 40 feet and makes one revolution every 8 seconds. You are the next to last person this is where you are, next to last person to get on. So when the last seat is filled, the Ferris wheel starts. You are seated as shown, right? Because it's going to move one, so we can see which way that it's going. You notice it takes 4 seconds from a seat to travel from the bottom of the Ferris wheel to the top, which is 45 feet above the ground. So from here to here is 45 feet. Oof. The diameter is 40, right? So from here to here, it's 40. So we can figure out some information. We should know this, right? Isn't that you're starting at 5 feet above the ground there. Each one of these heights is going to be a little bit more. Okay. What was I going to go with? So this right here is 20 and this is 20. So in this position, sorry, I stopped reading for a second. You're 25 feet above the ground. All right, so think about that piece. It takes 8 seconds to make 1 revolution. What else do we need to know? Let t be the number of seconds that have elapsed since the Ferris wheel started, and let d be your distance from the ground. Okay? So, we still have our picture of the Ferris wheel. We had written some stuff, and we can still go back to it. We want to sketch a graph. Or sketch a graph of the function, and then think about what type of function it is. So, this is going to be d of t. This is going to be t. And remember, this is, what did it say? Let t be the number of seconds elapsed since started. And this is going to be your y value, your dependent variable is going to be the feet, your feet above ground. So what we do know is that at 0 seconds, we're not sure what your height is. So let's come back to that. But we do know, so if it takes 8 seconds to go all the way around, it's going to take you 4 seconds to get to here. It's going to take you 2 seconds to get to here. Or this would be 2, this would be 4, this would be 6, and then back over here would be 8. So it's going to be, this would be 1 second, this would be 3 seconds, this would be 5 seconds, this would be 7 seconds. So we do know those pieces of it. And so those are really the ones that we want to focus in on because we know those heights based off of the given information, right? We know at 3 seconds, you're 45 feet above the ground. That's what it told me, right? We talked about on the last slide, I said, well, here, this distance is 20 and this little part is 5. So I know at 7 seconds, you're 5 feet above the ground. I know that at 1 second, you're 25 feet above the ground. Well, at 5 seconds, it's the same. All right. So even though I might not know it's 0 yet, we'll come back to that. We can fill in some of these other ones. So I'm going to go ahead and 1, 2, 3, 4, 5, 6, 7, 8 is what I'm going to go with. We know that it's going to go up to your highest is going to be, is that 45? And the lowest is actually 5. So let's figure out what's halfway between those. 25? Right? And that's where you are at 1 second. At 1 second, you're at 25. At 3 seconds, 1, 2, 3, you're at the highest point, which is 45. Goodness. At 5 seconds, you're back over here. At 7, you're at the lowest. Right? And then, I mean, if we kept going at 9, you'd be back at the midline. So this is going to be on that upward trend. Like we know it's going to be somewhere between 5 and 25. Right? And so I'm going to go ahead and I'm just going to sketch this. And I'm going to go with the 9. But I'm going to go up and then there's going to be a point that I don't really know too much about, and then I'll like put that as dotted, right? Just like we don't know, like we know this doesn't get all the way down to 5 yet. It's got to be on the downward trend, but we're not sure it's somewhere between those. But those are going to be the same values, right? So how exactly can we figure that out? Like, let's think through it logically before, and yes, I could work and write an equation right now and plug them in, and let's do that in a moment, right? Like we will do that. We'll talk about some of this stuff, but let's just think about it for a second. What is this angle in here? Isn't that 45 degrees? Right? Isn't this angle 45 degrees? So can't I figure out this little height? Don't I have this little right triangle? Pretty cool, right? I can relate it back to that. And I can go ahead and I know that the radius, don't I know the radius? I know the radius is 20, so like this distance is 20. It's a 45, 45 right triangle, so maybe I'd be able to figure out that height, right? That would be one way I could think through it. I've got that little triangle in there, and it's those two are congruent, and this is 20. These two angles are congruent, and this is a right angle, right? And if I know this distance from here to the ground, then can I figure out what's left here if I can figure out this little height, right? I want to know like I want to know this, and then I could go ahead and I could do 25 minus that. Couldn't I do that? Wouldn't that be kind of a neat way to do this? Maybe you remember special right triangles, or you remember like how 45, 45, 90s work. And I could go ahead and say I want to figure out this. I mean, I can even say like the sine of 45 degrees equals whatever it is over 20. I know the sine of that. It's 1 over root 2. So I've got 20 over root 2, or that's going to be 10, 20 root 2 over 2, so 10 root 2. Right, and so that height is going to be 25 minus 10 root 2. What's that approximately? 25 minus 10 root 2, about 10.86 feet. Does that make sense? Yeah, right? So like there's this point right here. That would be 8, about 10.86. That's going to be the same. Oh, no, it's not. Sorry. This height over here, that's going to be the same height as when they're at 6, right? Like that point's going to be over here as well. 6, 10.86. For the 4, that distance, like the 10 root 2 is still going to be up here, but I'm going to go ahead and do 25 plus 10 root 2. And I've got, that's like 39.14. So at 4, this is going to be like, I just lost my train of thought. What was it? 39.14. This is going to also be, so down here at 0, before they start at like 10.86 feet. Pretty cool, right? What's the lowest point you reach as the Ferris wheel turns? The lowest point is this spot right here, right? And that was 5 feet. Our model, y equals, well, we talked about the midline back here was 25, right? And then from the midline to the top is 20, isn't it? And the midline down is 20. Right? That's just essentially the radius of the circle. So you've got, I'm gonna go with sine, because I'm gonna work with this part. I'm gonna go from here to here. I don't have to, I think I'm gonna avoid using some of these rounded decimals that I figured out. And I also want to walk through like how could you do this if you didn't figure out those pieces, right? And you didn't use that right triangle, or you didn't think like that. So I'm gonna go with sine, and so I literally, 20 is the radius, right? 20 sine. 1 rotation is 8 seconds, so I'm going to have 2 pi over 8, which is pi over 4. X minus, right, when I figured that out, you were at spot number 1, so that was 1 second. So x minus 1, and then the middle is 25. let's use our model to predict some things. So I'm gonna try not to use my calculator because I have pi over 4 and I know how to work with pi over 4. So at 0 seconds, pi over 4, 0 minus 1 plus 25. 20 sine of negative pi over 4 plus 25. The sine of negative pi over 4 is going to be negative 1 over root 2. So this is 20 times negative 1 over root 2 plus 25. I'll pick up my calculator at the end. So I've got negative 20 over root 2, which is negative 10 root 2 plus 25. So negative 10 root 2 plus 25 gives me 10.86. So this 10.86 is approximate feet. What about at 4 seconds? 20 sine of pi over 4 times 4 minus 1 plus 25. Right, and these were the ones we kind of just figured this out before. 20 sine, that's 3 of 3 pi over 4 plus 25. Well, 3 pi over 4 is positive root 2 over 2. I don't know why I'm switching back and forth between them, but that's fine. It's good to recognize both. So 10 root 2 plus 25. So 10 root 2 plus 25, which is 39.14 feet. And finally, with this 9 seconds over here, you've got 20 sine of pi over 4 times 9 minus 1 plus 25. That's 8 pi over 4, 2 pi plus 25. 2 pi is that full rotation. So that's going to be, right, so you're going to end up right here. We already know this height. We know that one. Isn't that just 25? Isn't that just the middle? But let's see what happens here. So 2 pi, the sign is going to be 0. So you've got 0 plus 25, which is 25 feet. Pretty cool, right? How long does it take you to reach a height of 20 feet for the first time? Right, so where were you at 20 feet? Let's see. 20 equals 20 sine of pi over 4 x minus 1 plus 25. Right, so I've got negative 5 over 20 equals sine of pi over 4 x minus 1. I need my calculator. I could graph this as well, and I'll do that in a moment. No. Well, as you see, we're almost done. So I'm going to do sine inverse of negative 1/4, which is negative 5 over 20. And then I'll go ahead and multiply by 4 over pi, multiply by that reciprocal. And then I'll add 1. So it should be, if I'm doing this correctly, 0.68 seconds. Let's also take a look at the graph, and I've got other stuff in here, sorry. And in Y2, I'll put the 20, and in Y1, not the 205. Oh my goodness. Well, finicky. 20. And then here I've got, what was it? 20 sine and I should probably change this a little bit. So it was just 8 seconds. I'll go with 10. And then this I probably want it to be from like 0 to, I'll go with 50 so we can see it. Oh, what did I type in wrong? 20 sine pi over 4 x minus 1 plus 25. Oh, I missed a parenthesis. I didn't close that, so my calculator didn't know what it was doing. second insert, parenthesis. Now I'll graph it. There we go. Right, so where will you reach 120 the first time? So that's going to be right there. So let's go ahead and trace it. Oh, 0.678. Perfect, right? Very neat. All right, so you don't even have to worry about this homework because now you're done with it, right? So here was some more practice with applications. So ideally, you would have you have a pretty solid understanding of some of these applications. If you have not done part 1 of your homework yet, I would really encourage you to start taking a look at that to practice. And we will do some practice and writing equations, and you guys will have an opportunity to ask more questions when we're in class. So really take a look at that and see what questions you might have so that you are ready and prepared for class. Thanks everyone for watching, and we will see you all very soon.